For 610 and 611, for anyone that missed the class, I want you to just take a minute to read this. So pause me, and then we're going to talk about it. So go ahead and read just this top paragraph. There's no work to do. Pause me while you do that. I'm going to keep going and reading it. So pause me now. Great. In the past few decades, there has been a dramatic increase in the percent of people living in the United States who were born in other countries. This trend can be modeled by the quadratic function p equals this quadratic function, where p is the percent born outside the United States, and t is the number of years since 1960. So if we wanted to know, using this model, how many people currently in 2020 were born outside the United States that live here, we'd have to add 60 to this, so we'd take 60, because that would get us to 220, put it in for t, do the math, and it would tell us what percent of the United States is made up of people who were born in other countries. Kind of cool. All right. But say, and I'm sure maybe you or your family members or grandparents or great-grandparents were born in another country. I know my dad's parents were born in Ireland, and my mom's great-grandparents were born in Ireland. So they were people that were part of this model. Actually, they were here in the 1900s or early 1900s, 1930. All right, so say we wanted to predict when 15% of the population will be people who were born outside the United States. You could solve this equation. Put 15 in for p, and then solve this for t. So find the number of years since 1960 when it was at 15%. Okay. So if we wanted to do this, we'd have to use one of our methods. We'd have to factor, maybe graph. Take the square root. No, that doesn't work here. Or complete the square. To do any of those, it would be pretty tough or impossible to solve using factoring or completing the square, say, because of the numbers, right? Decimals and things like that. And we've talked about, like, physics is a quadratic formula, gravity, so these complicated formulas to solve them, like for the space flight or other physics problems that involve the world and science, they'd be like really hard to solve using factoring and completing the square. So mathematicians a long time ago figured out that there was a formula to use to find the answer to these questions. So, and we would spend a lot of time on it, but this is method 4, something called the quadratic formula. And that's awesome. So if you didn't, I told you, if you don't like method 1, 2, 3, or and you don't like a factor or complete the square or graphing, we can use the quadratic formula. Sweet, right? You know formulas from MCAS and things like that, like the area of a rectangle, the formula is length times width, A equals length times width. Or the area of, say, a circle would be area equals pi r squared. And you get a formula sheet. Boom. So we have a formula that we can use to find the solutions, the zeros, or the x-intercepts. Awesome, right? So here it is. Super simple, just like length times width. Or maybe not as simple, right? Here it is. This will calculate us the x-intercepts, the zeros, the solutions. And here it is. The x equals negative b plus or minus, we've seen that symbol recently, the square root of b squared minus 4ac all over 2a, divided by 2a. That's it. So we use that formula, we can get the solutions. Later year teachers will ask you to memorize it when you do tests and quizzes. So if they ever do, a student a couple years ago told me, Mr. Moran, if you sing it to the theme song of Pop Goes the Weasel, you might be able to have a better chance to remember it. So here it goes. If you're looking to memorize it, you can go Pop Goes the Weasel. And you may not know Pop Goes the Weasel, but there was those old Jack in the Boxes. So we're going to use that. x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Awesome, right? I'll sing it to you again. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, cool. Now you try it, or rewind me and hear it again. I'm kidding. It's just a fun way to remember, if you're looking to memorize it, use Pop Goes the Weasel. Okay, so what's all this b and a all about? Well, you can use a quadratic formula if you have a quadratic in this form. The a stands for the a in front of the x squared, the b is the coefficient of x, and the c is our constant, so we just plug it in. The one big key, the equation to use a quadratic formula must equal 0. Okay, so your quadratic formula, to use it, you must have a quadratic equal to 0, just like when we were trying to factor several weeks ago. All right, and then you don't need any of the other methods. So we're going to take some time to do a couple. And normally I would ask questions, but this is just the video part. So I have the quadratic formula here again. So we're going to use the quadratic formula to solve this quadratic equation. Okay, so take a moment, pause me, write this down. It's in the form x squared plus bx plus c. It is equal to 0, so we can use the quadratic formula. What I recommend is just making sure you list the a, b, and c's for the quadratic function, just as a way to stay organized. So our a value is a coefficient of x squared, 1. Our b is a coefficient of x, 2. And our c is our constant, negative 8. All right, once we've identified a, b, and c, it's just substitution. X equals negative 2, that's b, plus or minus the square root, b squared, 2 squared, minus 4 times our a value times our c value, all of it divided by 2 times our a, 1. So we just substituted it in, a, b, and c. There we go. Now we just need to simplify this expression over here, following orders of operations. So in orders of operations, it's, like a lot of people say PEMDAS, which I don't say, because P says parentheses, but it really means grouping symbol, so it should be like GEMDAS. And the square root is a grouping symbol, so we actually are going to go into there and follow that first. So we have negative 2, I don't know why I did it in purple, plus or minus the square root. Orders of operations just do exponents after, so 4 minus 4 times 1 times negative 8, all divided by 2 times 1, and we can do that right now. 2 times 1 is 2. Great. All right, next step is to follow orders of operations, and here's something that I do. It says minus 4, and to help students, I always say do plus negative 4 when you're doing this, because it helps you when you're doing your math and make mistakes with the negatives. So we have x equals negative 2 plus or minus the square root of 4 plus, we have negative 4 times 1 times negative 8, and that's positive 32 all over 2. All right, we'll keep going. X equals negative 2 plus or minus the square root of 4 plus 32, 36. All of this divided by 2. Okay, keep going. So x equals negative 2 plus or minus, well, the square root of 36 is perfect, so we can simplify it to 6, all divided by 2. And how do we resolve this? Well, there's 2 answers for x here. We have 2 problems. We have negative 2 plus 6 on top, divided by 2. And we also have negative 2 minus 6 we have to take into account. divided by 2. Let me zoom that out just slightly. All right. Negative 2 plus 6 is 4 over 2. Or we're okay with negative 2 minus 6. It's negative 8 over 2. So x equals 2 or negative 4. Yay, we solved it. Isn't that great? No factoring, no completing the square, no graphing. We found our answer. 2 or negative 4. Great, and you can use it every time. And you might be saying, Mr. Merriam, why didn't we just learn this at the beginning and skip all that other stuff? And that's a great question. Well, I'm going to show you here one way to think about it, and I want you to think about it. But so let's take that same problem, number 1. And what if we had tried to factor it first? Right? We think about maybe it could be factored. How many terms? 3. Is there a GCF other than 1? No. Look what's left. Can be factored more. It's in the form x squared plus bx plus c. So is there anything that multiplies to our c term, negative 8, and sums to our b term? Anything multiplied to negative 8 and summed to 2? Well, yeah, actually positive 4 times negative 2 works, right? 4 times negative 2 is negative 8, and 4 plus negative 2 is 2. So we can actually factor this. 2, because it's x squared, we can put an x and an x, plus 4 minus 2 equals 0. And now, using zero product property, we know what makes it equal to 0. Negative 4 for this one, or 2. And check it out, same answers. Okay. So why did we learn how to factor? Well, if you had an option to use the quadratic formula to get the answer, or try factoring, which one would you choose? I meant, it's clear, right? Factoring takes way less steps and might be a little simpler, right? You could see all the work it takes to use a quadratic formula. What if you made one subtraction mistake or one addition mistake? You would get the whole thing wrong, even if you did all this work, right? But if we had tried to factor, we'd be like, oh, got it. 2 steps, 3 steps, right? There's a lot of steps. Okay. So factoring is why we learn, because sometimes it's just easier to factor. But in reality, factoring doesn't always work. So here's step 2. Here's the second problem. So write this one down. Pause me if you want. We're going to first, to use the quadratic formula, we need to make sure it equals 0. So we're going to take 6 away from both sides. And we got x squared plus 4x minus 6 equals 0. Okay. We could try to factor. Anything multiplied to negative 6 adds to 4. I would tell you no. All right, so this can't be factored. So when it's not factored, we can do 2 things. We can complete the square, which we learned. So maybe you wanted to complete the square here. Or you could use the quadratic formula. Today I want you to practice the quadratic formula, so it's really good to list what a equals and b equals and c equals. So our a value in front of the coefficient of x squared is 1. B is our coefficient of x, and our c is our constant. Boom. Now we can just plug in. So x equals negative b, which is 4, plus or minus the square root of 4 squared minus 4 times a times c, all divided by 2 times a. Okay. One thing that I help, instead of showing all those steps that I think students have found useful in the past, is let's resolve this separately up here. Okay? So, and then we'll bring it back into the formula. So we have 4 squared minus 4 times 1 times negative 6. All right. And remember, I told you that maybe consider this instead of minus 4 plus negative 4, right? It might help with your math. So 4 squared, 16, plus negative 4 times 1 times negative 6 is 24. And then we add those, we get 40. Okay, so the square root symbol, inside the square root, you get the number 40. So now I get x equals negative 4 plus or minus the square root of 40 over 2 times 1, which is 2. And for now, because of where we're at with COVID, if you got there, you're done. Those are the two answers. Okay? It can be simplified a couple more steps, and we would have practiced it in school, but we're not going to do that. We don't have the time. I will take you one more step, if anyone's interested, but if you got there on the classwork, perfect. So one more thing we can do is, it says the top is being divided by 2. And you can do negative 4 divided by 2. And here, we haven't talked about it, so we're going to say for now, you can't just divide the 40 by 2. That's not how it works. So we can divide negative 4 by 2. So you get negative 2 plus or minus the square root of 40. But square root of 40 still needs to be divided by 2. So if you wanted to get there, that's cool. We can simplify it further, but this year we're not. Okay. I want you to try this one on your own. So go ahead and pause me right now. Make it equal to 0, and then try to get the answer down to this step. So pause me. For time-wise for the video, I'm going to keep going. First, to use a quadratic formula, I need to add 4 to both sides. I'm going to identify A, B, and C. So I plug them in correct. 5, 3, 4. I'm going to plug them into the quadratic formula. I'm going to resolve the square root up here. Make this plus negative 4. So it's square root of 9 plus negative 80. And get the 80. So I get the square root of negative 1 inside the square root symbol. I get negative 71 inside the square root symbol. So x equals negative 3 plus or minus the square root of negative 71. 2 times 5 is 10. So if you got there, that would be amazing. I hope you got there. One small thing we mentioned really briefly, there's no real number that's the square root of negative 71, so there's actually no real solution here. But we only briefly talked about it, but I just want to make sure you know that's the real answer. Okay. Classwork, page 587, you're doing 8 through 13. You're going to use the quadratic formula to do this. So make sure it equals 0, and maybe make sure you know A, B, and C. Some people got stuck on 8 when they were talking in class, but our A is 2, our C is negative 6. So what about B? Well, there is no B, so B must have been 0. There's no 0x. So when you plug it in, you're going to use B as 0. Okay, so that is the lesson for our last live lesson. So if you have questions, though, email, reach out. On Monday, or Tuesday, you need to come to class next Monday and Tuesday to take the district assessment. I don't know what's happening Wednesday and Thursday yet, but I want you to come to class on Monday and Tuesday for sure to find out, and you have to take the district assessment. If you take the assessment, I'm going to give you 100 out of 100 on your SIS grade. Okay, no matter what you get. All right. If you haven't done work, make sure you do it because the only thing it's going to do is benefit you. Okay. Thanks. Bye, everybody.